Adding and subtracting fractions. In order to add or subtract fractions, denominators must be identical. Really important. Okay. So they must be identical. So you want to make sure that your denominator is exactly the same. That's the only way to add it. First one, both of these examples, really simple because they're both have the same denominator. But the rule states that when you're adding, right, when you're adding fractions that have the same denominator or even subtracting, the denominator doesn't change. You don't just add them. Okay, the denominator stays the same. All you're doing is adding the numerator. So 3 plus 1 is 4. Now, is that the answer? No. Remember, anytime you have a fraction, first thing, after you've simplified it to, I guess, your fraction, and this goes for what we learned yesterday's lesson, always simplify it to lowest terms. So what can I divide evenly in both the top and bottom that will give me the exact same answer? 2. So if I'm going to divide top by 2, bottom by 2, and I get what? 2 over 5. Okay. Can I simplify that any further? No, I can't. Okay, so it's in lowest terms. Bottom one, let's simplify it. So, when we're subtracting fractions, same rule, right? The denominator has to be exactly the same. Right? They're both 15. That doesn't change. The denominator doesn't change. 9 minus 7? 2. Can I simplify that any further? No. There's your answer. 2 over 15. Okay? So now, looking back at what we talked about in terms of fractions, how many parts are there in our whole with this last example? 15. How many are we referring to? How many are we referring to? 2 from our whole of 15 equal pieces. Okay. Very good. So let's look at the following. Add or subtract the following fractions. Remember that answers must be in lowest terms. Now, can we just add our two fractions?
No.
Can we? No. Right? Denominators are not the same. So what we want to do is find a common denominator. Right? Find a common denominator. So look for, okay, some of the things that you can look for is, well, take the smallest one, right? Take the smallest of the two denominators and see, is there a number I can multiply that with that will give me the denominator of my other fraction? If I cannot, right, then we have to find the greatest common denominator, right? Or the lowest common denominator. So what can we multiply 2 by that will give me 10? Because remember, we might want 10 might be our denominator that we want, but this one for this example, yes, it will be. It will be 5, right? So we're going to multiply 2 by 5, right? But what I do to one side or to the bottom, I must do also to the top. Right? Now, when I multiply these, actually, let's just rewrite this one. 3 over 10, that doesn't change, right? Plus 5 over 10. 5 over 10 and 1 over 2. How are they related to one another? What are they referred to as?
They're both half.
Yeah, they're both half, but they're both equivalent fractions, right? So in other words, when you're writing and trying to find common denominators, right? What you're really doing is you're trying to find an equivalent fraction of one of your original fractions that you have in your question, right? So we couldn't add these two because they didn't have a common denominator. But to create a common denominator, you want to make sure, right? What you're doing is creating equivalent fractions. Because remember, equivalent fractions all mean the same. You all said that 5 over 10 is a half. Right? So it simplifies to that half. But now we're able to add it. So when we're adding it, now we can keep the denominator as is, which is 10. 3 plus 5 is 8. So is that our fraction? What can I divide top and bottom by? By 2. So I'm going to divide the top by 2. I'm going to divide the bottom by 2. And I'm going to get 4 over 5. Okay. Get the 2 and it becomes 4 over 5. Now, let's look at that fraction in terms of the equal pieces idea. So we have 2, 3, 4, 6, 7, 8, 9, 10 equal pieces. 10 equal pieces, and we're only referring to 3 of them. But now in our other whole, right, we've got 1 over 2. In order for us to be able to really add them, right, we have to be able to somehow divide our objects into equal pieces. Right? So we've got a whole, right, but this whole, both wholes, sorry, and I should have drawn them maybe, let me draw them, because in reality, if I'm referring to this whole as my 3 over 10, my other one would also be the same size, but it would be just cut in half. So in reality, what I want, right, this 1/2, I'm really cutting this half into tenths. 5, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Right? So in reality here, half of this, you know, this new hole that I've got here to represent this part, right, has to have the same number of equal pieces for me to add them. Right? So we're referring to 3 tenths, right, plus 5 more tenths to give us a total of 8 tenths, right, which would ultimately simplify then to 4 over 5. So when we're looking at the idea of, let's say, the pizza thing, or let's say this chocolate bar, so to speak, right, we're looking at it where the 2 holes have to be the same size, right? One of them is cut into 10 pieces. The other one is only cut into 2 pieces. They have to be cut into the exact equal pieces. Because we couldn't just look at it and go 3 there plus the original one that I had here cut into 2 and go, okay, well, we're referring to 1 over 2, so I'm going 3 plus that one, that's 4. But my whole, how many pieces is it broken into? One whole is broken into 2 pieces. The other whole is broken into 10 pieces. You cannot add fractions if they're not cut, the whole is not divided equally between all the objects. Okay. So, let's remove that. And let's solve this last one. Okay. Now, remember how we said we take the lowest one and we see what we can multiply it to try to get to the denominator of our other fraction. But really, can we go from 3 to 4? Multiplying? Exactly, we can. So we have to find a number that goes into, well, we got to find our greater number that both a 4 and a 3 can go into. That's 12, right? So, we know, so we put that as our denominator. But now, for me to go from 4 to 12, what am I multiplying 4 by? 3. For me to go from 3 to 12, what am I multiplying by? 4. Right? So remember, what I'm doing to the bottom, I must do to the top. But remember, I'm multiplying this fraction here by 3. I'm multiplying the other fraction here by 4. So, what's the numerator for my first fraction? 3. Right? Because 3 times 1 is 3. 2 times 4 is 8. Right? So now I have 3 parts I'm referring to of 12 equal parts subtracted by 8 pieces of 12 equal parts. Denominator doesn't change. 3 minus 8 is?
5.
Negative 5. Negative 5. Because we have a smaller number subtracted by a larger number. Okay. So our answer is negative 5 over 12. Now, just because there's a negative doesn't mean we don't look for to simplify. Can anything divide evenly in both the top and bottom? No. So our answer stays as negative 5 over 12.